Hey guys, welcome back to my channel Med Edophilia. And today we will continue with the next part of the chapter, which is measurement and errors. So the first topic here is the measurement of length. We have two methods here, one direct method and the second one is the indirect method. The meter scale, vernier caliper, screw gauge, spherometer, these are all the instruments which are used for measuring lengths, and this comes under the direct method. The first one being the meter scale is used for measuring lengths from 10 power minus 3 to 10 power minus 10 power 2 meters, whereas the vernier caliper is used for measuring length up to 10 power minus 4 meter, whereas the screw gauge and spherometer are used for much smaller lengths, that is less than 10 power minus 5 meters. For measuring lengths beyond these ranges, we use indirect methods. So this indirect method is usually very useful in determining the length of very large distances. For example, the distance between two stars, the distance between two planets, the distance between the sun and the earth, and so on. So such large distances we use indirect method, and one such method is the parallax method. So what do we mean by this parallax? So parallax is the difference in the position which of an object which we view along two different lines of sight. So let's consider an object O and say we are viewing the object from two different points here. So this difference in this position of the object when viewed along these two different lines of sight is known as parallax. Now this angle you see between these two lines of sight is known as the semi-angle of inclination, or the parallax angle, or the parallactic angle. This theta is very small because this distance here is very huge. We are measuring astronomical distances, that is very huge distances. So obviously the theta here is very small. Now the distance between the points of vision is known as basis. The distance between the two viewpoints is known as the basis. So as I told you, it has two applications. The parallax method has two applications, that is one measuring large distances of a planet or a star from the earth. Okay. So let's consider this. So here is an earth and we are trying to look at a far off star or a planet, any far off object for that matter, and we are viewing it from two ends of the diameter of the earth. So here the basis is nothing but the diameter of the earth itself, and here this angle theta forms the parallactic angle or parallax angle. So this theta is nothing but the angular size of the planet or the star. This is nothing but the angle subtended by the diameter at the earth. And this distance capital D is the distance of the planet or the star from the earth. Here you can see that this vertical distance and this distance is almost the same, okay, because they are very large distances. So from basic trigonometry we can see that theta is equal to B by D. This is just like what we saw earlier, that theta is equal to that is S is equal to r theta. Yes, didn't we see? That is arc length is equal to radius into the angle theta. This is very similar to that. Always remember that this theta should be measured in radians and not in degrees. So whenever they give you the value of theta in the question, you should always convert it into radians, whether it is given in minutes, seconds or whatever. Always convert it into radians, the SI unit. And the value theta is very small as the distance is large. As B by D, this ratio is very small. Okay, this D, the value of capital D is very large. So eventually the ratio B by D becomes very small, very less than 1. So now let's look at a question so that you'll understand this parallax method properly. So the question goes like, the moon is observed from two diametrically opposite points on the earth, and the angle subtended at the moon by two directions of observation is 1 degree 54 minutes. What is the distance of the moon from the earth, given that the radius of the earth is 64,000 kilometers? So here this question is just formula based. You need to understand the language of the question and try to convert it into a diagram. And the main part here is to convert the given angle into radians. So you should know the relation between degrees and radians, between seconds and degrees. You should know these interconversions, then your job will be easy. So now what are we doing here? We are observing a moon from the two diametrically opposite points on the earth. Okay, so here the diameter is nothing but the basis, and we know the formula theta is equal to b by d. So first our job is to convert this angle into radians. So we know 1 degree. We should convert this degree into radians. So first what we do is, there is a minute term here. So we convert minutes to degrees first, and then we convert degrees into radians in the end. Okay, instead of converting degree to minutes and then again converting, then it become long. So first always try to convert minutes to degrees and then degrees to radians. So we know 1 degree is 60 minutes. So we need to find how much is 54 minutes. So by just simple cross multiplication we get x as 54 by 60. So you should add. There is already 1 degree and here we have 54 by 60 degrees. So we know 180 degree is pi radians, isn't it? We have learned this. So 1 plus 54 by 60, what is it? 114 by 60 degrees is how many radians? So that is what we need to find now. So once again when you cross multiply we get theta is equal to 114 by 60 into pi by 180 radians. So substituting the value of pi as 22 by 7 or 3.14, we finally get theta as 0.033 radians. So now the value of theta is ready. Now all we have to find is b, basis. Basis is nothing but the earth's diameter, which is 2 into the radius, 2 into 64,000 kilometers. So we should always convert it into SI units, that is meters. So 2 into 64,000, 6,400, I'm sorry, into 10 power 3. Solving we get 1.276 into 10 power 7. So now we are only left with substitution of the values. On substituting we get d as 3.8 into 10 power 8 meters. Next we move on to estimation of very small distances. Firstly, we have the electron microscope, which has a resolution of 0.6 angstroms. So this electron microscope is very useful in resolving atoms and molecules in a material. Now what do we mean by resolve? Resolve means separating into individual molecules. So when they are so close to each other, the atoms, they almost appear like one single atom. So it helps in separating the two atoms so that we can observe as individual entities. Next we have the tunneling microscope, which has a better limit of resolution, which is better than an angstrom. So it can estimate the size of molecules. So electron microscope can only resolve the atoms and molecules but cannot estimate the size. Okay, but the tunneling microscope has a better resolution, hence it is able to estimate the size of the molecules. And 1 angstrom is 10 power minus 10 meters, and the wavelength of visible light, as we know, it is 400 angstrom to 700 angstrom. Now there is also a volumetric analysis, a volumetric method for determining small distances, that is like oleic acid, whose size is 10 power minus 9 meters. So for such small measurements, that is measuring size of molecules, we use the volumetric method. Now we move on to measurement of mass. For large mass like the planets and stars, we use the Newton's law of gravitation, which is F is equal to g m1 m2 by r square, where g is the gravitational constant and m1 m2 are the mass of the two objects which are separated by a certain distance, and r is that distance of separation of their centers. Okay, so by determining when we know the force and the distance of separation, we can easily find out the masses. So by using this we can find out however large the mass could be. Next, small masses, for example the subatomic particles like protons, electrons and neutrons, those masses can be measured by mass spectrography method. So the main principle of mass spectrography is that it uses the charge to mass ratio. Okay, this charge by mass ratio is nothing but the specific charge. Specific charge is always means, the word specific means by mass. Okay, when we say specific heat capacity, it is nothing but heat capacity by mass. So the word specific means by mass. Okay, but you might have heard this term specific gravity. Specific gravity means it is not gravity by mass. No, specific gravity here means relative density. It is dimensionless. Okay. Generally for other quantities the word specific denotes it is divided by mass. Specific charge means charge by mass ratio. Okay. Now if we take electron, let's see what is the charge by mass ratio. Charge of one electron, we are all familiar, it is 1.6 into 10 power minus 19 coulomb, and mass is 9.1 into 10 power minus 31 kg. So the ratio is 1.75 into 10 power 11 coulomb per kg. So learn this, the specific charge of electron is 1.75 into 10 power 11 coulomb per kg. Now let's take deuteron. What is deuteron? It is H2 1, that is it is an isotope of hydrogen which has mass of 2 AMU and its atomic number is 1. And when we take alpha particle, what is alpha particle? Alpha particle is nothing but helium nuclei. So it has a mass 4 and its atomic number is 2. So when we take Q by M, that is charge by mass ratio, for both we find that it is 2:1. Charge is to mass is 2:1. Sorry, mass is to charge is 1:2. Okay, I have taken the reciprocal. Sorry, mass by charge is 2:1 and charge to mass is 1:2. So here we find that for both these particles, for deuteron as well as alpha particle, they are the same. Hence by using mass spectrography this becomes difficult to distinguish whether it is an alpha particle or deuteron. So you need to know that the main principle behind mass spectrography is charge to mass ratio. Okay, now we move on to the measurement of time. So here we use an atomic standard of time. Okay, this atomic standard of time is based on the periodic vibration produced in the cesium atom. Okay, so this cesium clock, this is how the cesium clock is designed. This cesium clock is so accurate because there is an error of only 3 microseconds in 1 year. So they lose or gain not more than 3 microseconds in 1 year. So that is why we use the cesium clock as an atomic standard of time. So this is because of the tremendous accuracy in time measurement. We even define the SI unit of length based on this time. That is, we define length in SI system as the distance or path length travelled by the light in 1 by 3 into 10 power 8 seconds. So this 1 by 299,792,458 of a second is nothing but 1 by 3 into 10 power 8 seconds. Okay, approximately. So we all know the speed of light in vacuum is also 3 into 3 into 10 power 8 meter per second. So eventually this 3 into 10 power 8 in the denominator and the numerator get cancelled, leaving out the answer as 1 meter length. So thereby we define this 1 meter length, that is the length in SI unit, as the distance covered by light in this particular time interval. Now here is an important note, and there is a magic number which is 10 power 41. This 10 power 41 has a significance because it is nothing but the ratio of the longest to shortest length and time period. So what is 10 power 41? 10 power 41 is the ratio of the longest and shortest time length as well as time period. Now 10 power 41 the whole square is nothing but the ratio of the largest and smallest mass. So this is actually a coincidence which happened to be this same number. Now moving on, we need to know the difference between two terms which is often confused about and used interchangeably. No, there are two different meanings to each of the term. First one is accuracy. By accuracy we mean how close it is to the true value, the actual value. So when we measure any value, there will be a slight difference to the actual value to the measured value. So the closeness of the measured value to the actual true value is known as the accuracy. Now what do we mean by precision? Precision means the resolution or limit up to which an instrument can be measured. That is, for example, when we take a meter scale, a normal scale which we use in our pencil boxes, we find that the interval between successive units, that is, if you take 0 and 1, we have 9 divisions. So from 0 to 1 there is 10 divisions. Alright, so we say that it has 0.1 resolution limit or least count. So meter scale has a resolution of 0.1 centimeter. This resolution is nothing but the precision. For example, when we take vernier caliper, it has a greater resolution, greater precision of 0.01 centimeter. Again, taking screw gauge, it has a precision or limit or least count of 0.001 centimeter. That is, the screw gauge can measure up to 3 decimal places. Okay, so from all the three I have given, meter scale, vernier caliper and screw gauge, we find that screw gauge has a better precision of all, more precision, more resolution. Okay, now let me give you an example to make you understand that precision and accuracy are not the same, but they have a different meaning. Okay, let's take a pencil and let's say its actual value is actual length. Okay, it is 9.8 centimeter, and say there are three boys trying to measure the length of this pencil. Okay, and three boys, say John, Peter and David. Okay, and John measures the value of the length of the pencil as 10.84 centimeter, and Peter measures it as 9.7 centimeter, and David measures this as 9.2 centimeter. Now compare this with the actual value. Who do you think, whose measurement do you think is most accurate? Yes, it is Peter, because 9.7, 9.8, just 0.1 difference. So it is very close to the true value. So Peter is the one who is most accurate. Now, who do you think is more precise in his measurement? It is John, because his measurement contains up to 2 decimal places. That is, he was able to measure up to 2 decimal places. So this instrument which he has used has more resolution, more limit, more precision. So John, we can say, is more precise in measuring the length of the pencil. So what about this last guy, David? He is neither precise nor accurate. Okay. John, he is precise but he is not accurate. Okay. And Peter, he is most accurate but he is not precise, because the instrument he used for measuring he was able to measure only up to 1 decimal point. So this is all about measurement. And when we measure anything, it is bound to have some error in the measurement. So the next topic is errors. So error is nothing but the difference in the actual true value and the measured value. Now let's try and understand errors by classifying it. The first type of error is systematic error, and the second type of error is random error. Now let's look at systematic error first. The word systematic itself tells you that the reason for the error is known. That is, it tends to be in one direction, either positive or negative. Okay. If it is positive error means the measured value is more than the actual value. It has a positive difference. And if the measured value is less than the actual value, it means that the error is negative. So it is, or we always know that it is in one direction, either positive or negative. Okay, now let's look at the types of systematic error, the sources of systematic error. First one is the instrumental error. Instrumental error is of two types again. First one is due to imperfect design or calibration of the measuring instrument, and the second one is the zero error. What do you mean by imperfect design or calibration? Yeah, the instrument itself is not designed properly in order to measure the actual value. So it is due to that instrument. Second one is zero error. That is when the zero mark of that instrument is not coinciding with the zero mark of the main scale. So because of not coinciding, this zero error arises. The second type of systematic error is the imperfection in experimental technique or procedure. That is when we not know how to actually do the measurement. That is how to do the experiment in order to measure that object. Okay, so in that cases this occurs. Third one is the external condition like temperature, humidity, and so on, which occurs during the experiment itself, and it's quite predictable. Okay, because the external conditions may not cooperate with your experiment. Okay, next comes the fourth one, which is biased personal errors, which can be due to improper setting of the apparatus, or it can be due to the carelessness of the person who's doing the experiment, that when we not take the proper precautions. All this comes under biased. Okay, biased personal errors. So here parallax error is an example of biased personal errors. So what do we mean by parallax? We know it is viewing. It occurs due to viewing an object from different position. Okay, that is how the parallax error arises. Now here you should note carefully that personal error can be two types, biased and unbiased. When it is biased, okay, we know it. Okay, in that case it will come under systematic errors, and when it is unbiased it comes under random errors. Now let's look at random errors. As the name suggests, the cause of the error is not known. It's not in a particular direction. It can be either positive or negative. We don't know. It's very random. Okay, it is unpredictable, it is irregular. Okay, let's see what are the types. First one is due to unpredictable fluctuation in experimental conditions like temperature, voltage supply, and so on. Here there also we saw that unpredictable external condition, but yeah, we saw that the systematic error, under systematic error we saw due to imperfection in experimental technique or procedure. That is one point we saw, and next point we saw was that the external condition, that is again there also we saw temperature, humidity, and velocity. So you might ask, both points are one coming under systematic, here coming under random error. So what is the difference? Both was regarding the external conditions, but why are we differentiating? What is the difference? So I will tell you. For example, there is a rainy season and we can expect rain at any time. We know that in rainy season a heavy rain coming is quite predictable, right? So here this comes under systematic. But now when we have summer season and suddenly there is a rain which is unexpected, we never expected. There's a bright sun shining outside and we never expected a rain. In that case, which is unpredictable, okay, randomly occurred. So we now say that this rain is due to random errors. This comes under random errors. Do you understand the difference now? Okay. The next type is by unbiased personal error. Unbiased itself, the word itself tells you that it's not biased. Okay. We don't know. So this type of personal errors is due to the readings that we take, okay, by the observer taking readings and so on. So it is unbiased. So here you should know the difference between biased and unbiased. Okay, so how can we reduce this? By repeating the observations several times, we can reduce random error. That is, when we increase the sample space for observation, when we increase the reading, the errors decreases and the accuracy in the measurement increase. Okay, thereby we can improve our measurement. So while talking about precision, I mentioned the word least count. Least count is nothing but the smallest value that can be measured by that instrument. Okay, and whenever the error is not known, the error of the instrument is not known, it mainly occurs due to the least count. So least count error is the error associated with the resolution or the precision or the limit of the instrument. Okay, so here is an important line from MCQ point of view. Okay, that least count error belongs to the category of random errors, but only within a limited range. Okay, but generally speaking, least count errors can occur due to systematic and random errors. So only within it's actually a random, it is a type of random error, but only within a limited size. But generally speaking, it is both systematic as well as random errors. Okay, now we move on to calculation of errors. First one is absolute error. Okay, absolute error, as I told you, is nothing but the difference in the true value minus the measured value. So here we are taking A1, A2, A3 as the different measured value of a quantity in an experiment performed several times. Okay, and what do? We take the mean of this A1, A2 and A3. What is mean? Total, the sum of all the values by total number of observations taken. So A mean for an experiment performed n times will be A1 plus A2 plus A3 in so on till an by n. Okay, so this we are actually finding the mean value of that measurement, and now we find del A1, del A2 and del A3 and so on till del Am. So what is that? Del A1 is nothing but del which is A mean minus that individual value A1, and del A2 is nothing but A mean which we found out now minus A2. Okay, and del A3 is A mean minus A3. Okay, similarly we find till An. Okay, so del A mean is nothing but the mean of all the errors we found. That is del A1 plus del A2 so on till del An by n. Or if you find this little long, what you can do, it is nothing but del Am minus del An, the nth value. Okay, you can directly substitute and find. Now we have to find the relative error. Relative error is nothing but it is the ratio of del A mean by A mean itself. Okay, this ratio is known as relative error, and when you multiply it by 100, it simply becomes percentage error. So percentage error is nothing but relative error into 100. Okay, so now let me give you a question so that you understand the calculation of errors better, because everything here in physics you need to understand using a question. Okay, the question goes like, the period of oscillation of a simple pendulum in the experiment is recorded as 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds and 2.80 seconds respectively. Find the average absolute error and we have given with 4 options. So what is average absolute error? They are asking us to find del A mean. So del A itself means error. Okay, this del represents the difference, the error. Okay, and we have to find average. Average or mean, both means the same. The first step is finding A mean, the mean value of the given quantity. Okay, the given time period of oscillation is a physical quantity, and we need to find the mean of A1, A2, A3, okay, A4 and A5. Okay, so simple, we should simply add them and divide it by 5 because there are 5 readings recorded. By doing that, we will get the answer as 2.62 seconds. So that is our A mean. The first step is over. Second step is to find out del A1, del A2, del A3. So what is del A1? Del A1 is nothing but the average value, that is A mean minus A1. Del A2 is A mean minus A2. Del A3 is A mean minus A3. And here remember, we always take the absolute value, that is the positive value. So we are finding the difference and we write it down. 2.63 minus 2.62, which is 0.01. Again for del A2, 2.62 minus 2.56, which gives us 0.06. So here we take only the absolute value, no sign, whether it's positive or negative, you just write the absolute value. Similarly, we find for other things till A5 we are finding. Okay, now what do? We have to find the mean value. How to find the mean value? Add everything, add all the differences and divide it by 5 because it's the total number of readings taken. So 0.01 plus 0.06 plus 0.2 plus 0.09 plus 0.18 divided by 5, you get 0.54. Okay, so what do? 0.54 by 5, we get 0.108. So you should round off the 0.108. So how do you round off? Will you round it off as 0.101, or will you just leave it as 0.10 because 8 is because 0 it is even and 8 is greater than 1? Will you just leave it? No, for rounding off question, okay, normal rounding off question, we use the rules which we saw earlier. That is, if it is even, you just leave it. If it's odd, then you have to add 1. But here you need to round off, and this is within the question. Okay, so for rounding off within the question, you should use normal method which we generally use in maths, that is, which is greater than 5, whether it's odd or even, you simply add 1. Okay, for that you add 1. Okay, here that's why we get 0.11 second as the final answer. So for a question exclusive for rounding off, we use the method which we studied in the earlier video. All right, so this is something no one will tell you, and this is something which you really need to keep in mind for you to get your answers right. Okay, now let's look at the operations involved within the topic errors. First one, sum or difference. Here what you need to remember is that errors are always added. Okay, now let's see a question. Okay, let's say I give you that volume of a container A and container B are measured as 2 plus or minus 0.02 centimeter cube and 6.6 plus or minus 0.06 centimeter cube respectively. Now find the total volume of milk that can be stored in these two containers. So what should you do? Simply add them. So add the numerical part, you will get 2 plus 6, 8, plus or minus the errors should also be added, plus or minus 0.08 centimeter cube. Now I give you the next question. How much more milk can be stored in B than A? Okay, now what should you do? It's nothing but the difference of the volumes. So it is 6 minus 2, 4. Now what should you do? Should you add the errors or subtract the errors? Will it be 4 plus or minus 0.04 centimeter cube because it is difference? No, this is wrong. Why? Because errors are always added. So the correct answer will be 4 plus or minus 0.08 centimeter cube, and that is correct. So when two quantities are added or subtracted, the absolute error in the final result is always the sum of the individual errors. Sum of the absolute errors in the individual quantities. Okay. The next rule. The relative error in a physical quantity raised to the power k is k times the relative error in the individual quantity. So to understand this, I'll give you an example. For example, Z is a some physical quantity and it is equal to a cube. So what is the relative error in that physical quantity? It is nothing but del Z by Z is equal to 3 times del A by A. So we are bringing this 3, which is the power, in the front. So this will become the relative error in the physical quantity. So power k will become k times the relative error in that individual quantity. Are you understanding? Okay. So let's move on to the next thing, which is division or multiplication. For understanding this, I'll give you a question. Say z is equal to m cube n square into ab by q power 5 by c. Now we have to find the relative error in z. Now what should you do? Del z by z is equal to, bring the power to the front. So it will become 3 into del m by m, that physical quantity m, plus, always add, okay, whether numerator or denominator, always add, plus 2 del n by n plus del a by a, because it's a power 1, there's nothing on top of a. So del a by a plus del b by b plus 5 del q by q. If q is in the denominator, yet there is a plus here. So remember that, plus del c by c. Now I'll give you another question. Try it out on your own. Say there's a physical quantity r and r is equal to x square y cube z power minus 1 by 2. What should you find? You should find del r by r. So come on, pause the video and try it out. So yes, so when you solve, bring 2 to the front, you'll get 2 into del x by x plus 3 into del y by y plus 1 by 2 del z by z. So whether it is a negative power or positive power, whether it is the numerator or denominator, always you should add. Just bring the power to the front. So z power minus 1 by 2 is nothing but x square y cube by, the minus denotes it is division, isn't it, by z power 1 by 2. That's why we get like this. Now I give you another question. Calculate the fractional error of this physical quantity r, where r is equal to x plus x by x plus y. So now what do we do? Del r by r is equal to del x by x plus the numerator term as such, plus del x plus y is the term in the denominator. So you write that as such, del x plus y plus by x plus y. Now what should you do? Split this. So solving it, what will we get? Is equal to del x by x plus, bring this, open this bracket, we will get del x by x plus y, which is the denominator as such, you write like that, plus del y by x plus y as such. So this becomes the final answer. Now I will give another question. Given that the length and breadth, okay, length is 4 plus or minus 0.04 meters and breadth is 2 plus or minus 0.02 meters. Now find the area with proper error limit. What is the area of this rectangle? Simple, it's length into breadth. 2 into 4, 8. Now what should we find? We should find the error of area. Whenever we should express it as a plus or minus del a, like how length is expressed. So for that we need to find del a first. So del a by a, or write the expression for relative error. Use that concept here. We write del L by L plus del B by B. Why? Because area is nothing but length into breadth, right? So is equal to 0.04 by 4. So this, the term next to the plus or minus is nothing but the error. So error in length is nothing but 0.04 by 4 plus 0.02 by 2. On solving, we get 0.01 plus 0.01, which is 0.02. So del A by A is equal to 0.02. So from this we can find del A. Bringing A to the other side, we get A, we already know we have calculated it as 8. So we get 0.16 as the error in the area. So the final answer, that is when we express area in proper limits of the error, we get 8 plus or minus 0.16 meter square, because it length into breadth, meter into meter, meter square. This unit is also important. Okay, now let's see a question in percentage error. Okay, so the question is, the percentage error in mass and length of a wire is 2% and 1% respectively. Find the percentage error in the density. So wire is nothing but a cylinder, we all know. Okay, so for cylinder, what is the volume? It is pi r square h, isn't it? So density formula we already know, it's mass by volume. So mass by pi r square h. Okay, so how will you write the relative error in density? Del d by d is equal to del m by m plus 2 times, because it's r square, right? So 2 times del r by r plus del h by h. So here the height is not given, right? So okay, no, the radius is not given. Okay, so let me give the percentage error in the radius as 3%. Okay, so mass is 2%, radius is 3%, and length is 1%. Length and height both are the same here. So what should we do when we here everything is in relative error concept. So when we do into 100, it becomes percentage error. So what we finally need is the percentage error, and everything is given in terms of percentages. So simply what we can do, into 100 on both sides, you can simply take this del m by m into 100 as 2% plus 2 into 3% plus 1%. So when you add, you will get 9%. So this 9% is the final answer. So the error, the percentage error in the density of that wire is 9%. So now we conclude with the final thing. We finished with errors. Okay, now we are only left with screw gauge vernier caliper. If you want this, please comment it. I will teach this separately. And anyways, I will be doing this along with the questions. I told you, right, there will be a question solving session after this. We finish this chapter is over with this, only this concept is left. So anyways, I will be doing this with the question series, which I will be posting as a next video. So when I do this question related to screw gauge and vernier caliper will be covered. So based on that, you will also come to know the actual concept behind when we discuss each question. So at that time, anyways, this thing will be covered. If you still need the topic to be covered in detail, then please comment it. I will definitely see to that I will cover the video of vernier caliper and screw gauge also. So yeah, that's it. We've completed the chapter successfully. So like, share and comment if you've liked the video and if you've really understood the concepts well. Thank you so much.